have a look at this question over here. All right, I know that I need like bases everywhere. All right, so this and that need to have the same base. So I'm going to change 16 to 2 to the power of 4 multiplied by 2 to the power of 2. All of this multiplied by to the power of x plus 3 is equal to 2 cubed all to the power of x minus 2. All right, now I need to get rid of the brackets, so I'm going to distribute on both sides. So I'm going to end up with 2 to the power of 4 multiplied by 2 to the power of 2x plus 6 is equal to 2 to the power of 3x minus 6. Okay. Oh, and I think what we forgot here is that we need to add like bases. Okay, like bases are being multiplied on this side. Therefore, we must keep the base and add the exponents. I will forget that there was a 16, but the rest of it was correct. You were going to get marks for method, my guy. This was going to become 2 to the power of, well done, a sweet for Abu. He remembered to say keep the base. There we go, there's a sweet for you. This becomes 2 to the power of 2x plus 10 because I've got 4 plus 2x plus 6. All right, and that is equal to 2 to the power of 3x minus 6. Now that I have like bases, I can drop them and I can make my exponents equal. Therefore, 2x plus 10 is equal to 3x minus 6, right? And then I'm just going to shift things around. The 3x will come over and the 10 will go over. Therefore, 2x minus 3x is equal to negative 6 minus 10. 2x minus 3x will give me negative x is equal to negative 16. Therefore, x is equal to 16. All right. There we go. And that's the answer we're looking for. Quite nice and simple. All right. We're going to continue with our exponential equations really quickly. And then halfway through, we're going to start rational exponents. But rational exponents are exactly the same as everything else we've been doing, guys. We're literally doing nothing different. It's in line with exponents. So it's not going to be like a huge shocker to us to see them. All right. I know that in our class, we tackled these two questions on Monday. Did we do this question here? Does anyone remember? This one where we had to look on both sides if we managed to get the same answer. Did we do this question? Yes? No? Anybody remember? Okay. Well, if we haven't done this question, then I'm going to give us a chance to do this question over here. We are solving for x, and also if you already remember the answer to this one, have a look at this one as well, because that's where we're going to start today. All right. I think we did, guys. I'm pretty sure we did this question. Do we remember me saying that we should divide both sides by 8 and we should divide both sides over here by 2 to the power of x? Yeah, and 2 to the power of x. Yeah, see, I remember we did that because now these two will cancel. Sorry, Narisha. These two will cancel and these two will cancel. So we will end up with 3 to the power of x over 2 to the power of x is equal to 27 to the power over 8, right? And then we said over here we can take it 3 over 2. We can split it and we can write 3 over 2 all to the power of x is equal to, I know 27 can be written as 3 cubed over 2 cubed, and then we can take 3 out as a common factor. So what we're technically going to have is 3 over 2 all to the power of 3. My bases are the same, therefore they will cancel, and that means that x is equal to 3. We did this one. All right, and I even remember somebody, I think it was Kulani, who said we must remember to factorize when we come to this next question over here. So let's talk about the second question that we've got over here. I'm going to remind you guys, if I said to you guys that I've got a question that looks like this, I know, But Abu, if you want the full explanation of that question, we need to go to the recording of last week's lesson. I mean, Monday's lesson. Okay, because I explain it in detail in the recording of Monday's lesson. Okay, so if I say to you guys, I've got 2 to the power of x, I knew you did, plus 2 to the power of x plus 1, correct, over 2 to the power of x. I know, absolutely, Hilani, that because there's a plus in the middle, we must factorize, or rather, we need to split and factorize. We must split and factorize. Now, if we had to split and factorize over here, let's start by splitting. I'm going to get 2 to the power of x plus 2 to the power of x times 2 to the power of 1 over 2 to the power of x. And just as Hulani is saying, we're going to take out an HCF of 2 to the power of x. So I'm going to get 2 to the x. If I open brackets, if I take that out, I'm then going to get 1. There's a 1 out plus 2 to the power of 1 over 2 to the power of x. And then my 2 to the power of x's will cancel, which means my final answer is going to be 1 plus 2, which is equal to 3. That's my final answer over there, right? Now, on this side, I'm going to note that the two things I want to compare, the 9 and the 3, do not have like bases. So I'm going to change my 9 over here to 3 squared. Right, we're going to start there. Okay, I want you guys to go ahead and do that question. Pop your favorite emoji in the chat for this question. If you do get an answer, I'm going to give everybody 3 minutes to try this question over here. Okay, and if you're done with that question, you can also try this question for me. 2 to the power of 2x plus 3 plus 4 to the power of x is equal to 36. All right, try both of those for me. Please pop your favorite emoji in the chat when you're ready. I'm going to quickly pop my favorite emoji in the chat because, like, I ain't even going to lie, guys. I'm like 5-2 holiday mode. I'm ready. Where is my favorite emoji? Where's my emoji of the day? Let me see if I can find it. I'm not finding it, but I will. There it is. Holiday mode equals activated. There's my emoji of the day. Don't ask me why I'm wearing jeans and a jersey on the beach, but yeah, it is what it is, guys. It is what it is. No, Narisha, it's complicated. It's complicated. Don't ask too many questions. It's complicated. One more minute, guys. All right, peeps, that's time. Okay, let's have a look at this first question that we've got on the left-hand side. All right, I know that I can write 9 to the power of x as 3 to the power of 2x plus, now I'm going to split this one over here into 3 to the power of 2x times 3 to the power of 1 is equal to 36. Okay, I'm going to keep the 36 for now. We'll come back to why we haven't written it as a product of its prime factors. It doesn't really matter at the moment. All right, not yet anyway. So I know that I've got an HCF on this side of 3 to the power of 2x. If I take that out, I'm going to have 1 plus 3 to the power of 1 is equal to 36. I now have 3 to the power of 2x multiplied by 1 plus 3 will give me 4 is equal to 36. And then I can divide both sides by 4. To get rid of 4, I divide both sides by 4. So this is going to give me 3 to the power of 2x is equal to 36 divided by 4 will give me 9. That means that 3 to the power of 2x is equal to 3 squared. And then I can drop my bases. Therefore, 2x is equal to 2, and that means that x is equal to 1. How many of us managed to get that one? Yeah, how did we do? All good, everyone? No? Nobody? Okay. Sorry, guys. I know it's the last day. I think, Hulani, you missed a step. Like, did you get to the right answer, though? It depends on which step it was. No. Oh, I see. Okay. Excuse me. Don't drop the braces. Oh, Narisha. Okay, let's look at this next one over here. All right, we're going to do the exact same thing, guys. It's just we know that we need to change 4 to the power of x because we need the same base on both sides. So I'm going to get 2 to the power of 2x times 2 to the power of 3 plus 4 can be written as 2 to the power of 2 times that x that's already there is equal to 36. I'm going to factor out 2 to the power of 2x. And what I'm going to get left is 2 cubed plus 1 is equal to 36. Right? I'm then going to get 2 to the power of 2x multiplied by 2 to the power of 3 is 8 plus 1 is 9 is equal to 36. And then I'm going to divide both sides by 9, divide by 9, divide by 9. Right? And that's going to give me 2 to the power of 2x is equal to 4. I know that 4 can be written as 2 squared. I'm just going to continue over here. 2 to the power of 2x is equal to 2 squared. And then I'm not going to drop the bases. I'm going to gently put them down so that Narisha doesn't say we're giving them brain damage. We're gently going to put the bases down. And then we're going to work with the exponents. Therefore, 2x is equal to 2. And therefore, x is equal to 1. You know, in Narisha's world, maths things just have feelings and you know, and a mind of their own. They even have careers and, you know, universal problems. In Narisha's world. I'm here for it, though, my darling. I'm here for it. All right, let's look at this next question over here because this one is a proper NB. It's a hard one. All right, because what we're going to note is if we change 25 to the power of x to 5 to the power of 2x, 5 to the power of 2x minus 6 times 5 to the power of x plus 5 is equal to 0. We're going to notice here that we do not have an HCF. In fact, even if we did have an HCF, we would still have a problem because this is 5 to the power of 2x, and that one is 5 to the power of x. It's two completely different things. Even if we took out a highest common factor, which we can't because 5 doesn't have an x over there, we know that something else needs to be done here. So we're going to go back to our trusted old friend, K substitution. We're going to go back to K substitution because K substitution is it's gonna save our butt every single time, guys. Every single time. All right. Let's talk about what we can do with this 5 to the power of 2x. I'm going to do this, guys. Here's what I'm going to do. I'm going to take 5 to the power of 2x, and I'm going to split it like this. I'm going to go 5 to the power of x all to the power of 2. Is everybody okay with why Teacher Coco has done that? Give me a yes or a no in the chat. Okay, Vukosi says no, which means I'm going to have to explain again. All right, so Vukosi, let's say I give you this. If I give you 25 to the power of x, right? I know that in order for me to change this, this becomes 5 to the power of 2 all to the power of x. Yes? Are we okay with that? Right? And then what I'm going to do is I'm going to multiply these two in. Correct? Then I can multiply them in. So I end up with 5 to the power of 2x. Okay, now what I'm doing, instead of doing it this way, I'm doing it in the opposite direction. I'm doing it in the opposite direction. So when I have 25 to the power of x, I'm just doing this. I'm just going 5 to the power of x to the power of 2, because it's going to give me the exact same answer. I'm going to take 2 times x, and that's still going to give me 5 to the power of 2x. Are you okay with that? Okay, and there's a method to my madness. There is a method to my madness. Are we okay with that idea? Excellent, good. All right, so here's what I'm going to do now. I'm going to write that as 5 to the power of x to the power of 2 minus 6 times 5 to the power of x plus 5 is equal to 0. And then I'm going to go over to the side and I'm going to say, let k equal 5 to the power of x. All right, so wherever we see 5 to the power of x, we're going to replace it with a k. So what I'm going to get over here now, there's a 5 to the x. I'm going to get k to the power of 2, because the 2 was already there, minus 6 times k plus 5 is equal to 0. Has anybody noticed it yet? Have we picked up on it? Who's got it? Ah, there we go. Yes, princess. Yes, it's a trinomial, correct. And then we can factorize, because we know how to use the zero product law, and we can use that to factorize our trinomial. So we're going to open 2 brackets. K is equal to 0. I'm going to get k and k. I need to make -6. I need both of them to be -1 and -5. Those are the only factors of 5 because it's a prime number. Therefore, k is equal to, Teacher Coco. K minus 1 is equal to 0, or k minus 5 is equal to 0, right? That means that k is equal to 1, or k is equal to 5. But we're not done, because we know what k is actually equal to. K is equal to 5 to the power of x, right? So this actually means that 5 to the power of x is equal to 0. Oh, sorry, is equal to 0, is equal to 1, or 5 to the power of x is equal to 5. So what two values do I have for x? Excuse me, guys. Still got that cold. All right. I know that I can rewrite 1 as what? How else can I rewrite 1, guys? Yes, that's it. That's it, Narisha. Beautiful. I'm going to get 5 to the power of x is equal to 5 to the power of 0, or 5 to the power of x is equal to 5 to the power of 1. And then we'll gently lay down each of our bases. And that means that x is equal to 0, or x is equal to 1. All right. Are we okay with that? Yes. It's quite all right. It's all right. Here's another example for you guys to try. All right. 9 to the power of x minus 12 times 3 to the power of x plus 27 is equal to 0. Take it away, peeps. Pop your favorite emoji in the chat when you're ready. Ngozi, are you all done? If you are done, damn, that was fast. Sure. That was super duper fast. Oh, okay. Yo, I was about to say, yo, you need to come teach me some maths because I don't think I could have finished in that little bit of time either. One more minute, guys. All right, guys, that's time. Let's have a look at this question. All right. So I'm going to take 9 to the power of x, and I'm going to rewrite this as 3 to the power of 2x. And Narisha just finished, just in time. Minus 12 times 3 to the power of x plus 27 is equal to 0. Now, remember, I can rewrite this part as 3 to the power of x all to the power of 2. because 2 times x is still going to give me 2x. So it's perfectly fine for me to do it that way, right? Plus 27 is equal to 0. Then I'm going to go over to the side. Let k equal 3 to the power of x. And that's going to give me k squared minus 12k plus 27 is equal to 0, right? And then it's a trinomial, so I'm going to open 2 brackets, equals 0, k and k. I need factors of 27 that are going to give me negative 12. Well, there's only 2 options, really, negative 9 and negative 3. Correct, Narisha, beautiful. Right, therefore, k is equal to 9, or k is equal to 3. Now, I've skipped a step here, and we are allowed to do that because factorizing things this easy is actually a grade 9 concept and not a grade 10 concept. So I'm allowed to skip that step where I go k minus 9 equals 0 or k minus 3 equals 0. They're not even going to mark that section because you should know how to do it already. You learned how to do it in grade 9. So they're just going to go straight to, we can go straight to k equals 9 or k equals 3. That tells me that 3 to the power of x is equal to 9, or 3 to the power of x is equal to 3. Oh my goodness. Ah, Darisha, you're killing me. Okay. If you have trust issues with maths, go ahead and do it. Okay. Correct, Theo, correct. So we're going to get 3 to the power of x is equal to 3 squared, or 3 to the power of x is equal to 3 to the power of 1. And then again, for Narisha's sake, because she has trust issues, we're going to gently put down, we're gently laying down our bases, and therefore x is equal to 2, or x is equal to 1. I know, you know what, Narisha, I have an older sister who used to do that as well. Like even the simplest of things, she used to put in a calculator because she's like, I don't trust this. Especially the negative numbers. She used to forget all the negative numbers, so she used to put them in a calculator. All right. Okay, guys. Okay. Let's have a look at something different, because today's lesson isn't actually on exponential equations, which this is great. We've done this. We now understand that we can use case substitution for any of these questions and find the answer. If it's not factorizing the way that we needed to factorize, your best bet, guys, is to use K-sub. K-sub is a lifesaver. All right. So what we're actually going to be doing today is we're going to be talking about rational exponents. Okay. K is a hero. K is such a hero. All right. So rational exponents, or the idea of rational exponents, actually stems from rational numbers, right? Rational numbers. And we know from learning about our number line that rational numbers are all numbers that we can pretty much write as a fraction. That's what those are, right? Anything that's written as a fraction. Now, in this case, we can see rational exponents just means that our exponent is the fraction. That's what it means here. But the rules of exponents don't change when we deal with rational exponents. Not at all. We're going to do the exact same thing that we've been doing with all the other calculations. Now, I want you guys to just bear with me one thing. When we look at a rational exponent over here, so when I have 1 over 3, this is actually the same as the cube root of 27, which we know the answer to. We know that the cube root of 27 is actually just 3. We know that the cube root of 27 is 3, right? Now, in this case, if I asked you guys, if I said I have 25 to the power of a half, that is the same thing as the what root. What root would this give us? The what root? If we think about it, to the power of a half would give us the what root? Who's got an idea? If 1 over 3 is the cube root, 1 over 2 would be the what root? Yes, that's it, Theo. Absolutely. It would be the square root. It would give us the square root of 25. And we know the answer to that. The answer to that is 5. But let's see how the rational exponent part actually comes in, right? Here's what we're actually going to do with these particular questions, right? We're going to take 27 and we're going to write it as a product of its prime factors. So we know that 27 actually ends up as 3 cubed all to the power of 1 over 3. And then I see a bracket and an exponent. I know that I'm going to multiply my exponents. That's going to give me 3 to the power of 3 times a third will give me 3 to the power of 1, which exactly proves my point. All right, are we all okay with this idea? Not a difficult idea at all, right? Pretty easy. We're just going to take what's in the bracket, put it as a product of its prime factors, and then work our way backwards. Okay, give me a thumbs up. Everybody okay with what ma'am has done here? Excellent, princess. Okay, so the fraction is actually like this. So over here, I'm in a way I have 3 times 1/3. That's the same as 3 times 1 over 3. And if I wanted to change 3 into a fraction, I would have 3 over 1 times 1 over 3. And then I know I can cross cancel. So I basically have 1 over 1, which is just 1. Are we okay there? Amina, did that answer your question, or would you like me to do it in a different way? No, my darling, we don't have to tip in times because we're multiplying. We're not dividing, we're just multiplying. Okay, so all I've done here, and my nose just got super clogged up. All I've done here is I've taken 3 times 1 over 3. So I've just gone 3 times 1 over 3. Now, remember, any number sitting on its own, if I want to write that as a fraction, I'm just going to put it over 1. Okay? And when I multiply fractions, let's say, for instance, we don't cross cancel. When I multiply fractions, I must multiply the numerator with the numerator and the denominator with the denominator. So 3 times 1 will give me 3 over 1 times 3, which will give me 3. And 3 divided by 3 will just give us 1. Okay, cool beans. All right, guys, I really need to go blow my nose. So I'm going to give you guys 4 questions to try. Okay, pop your favorite emoji in the chat when you're ready. Okay, I'm going to go blow my nose before because I can't breathe. I can't breathe right now. I'll be right back. Theo, did you put on the mask emoji because you saw me coughing? I feel like low key that was for me. At least it's a good thing for your sake, Theo, that these are online lessons and you're not sitting in the room with me. Otherwise, just for that, I was gonna come cough on you just for that comment. I was gonna come right up to you and All right, peeps, let's have a look at these answers. Okay, questions 1 and 2 should be pretty okay. It's about question 3 where it gets a little bit hairy, but it should be easy enough for us to do. All right, I know I can rewrite 125 as 5 to the power of 3 to the power of 1/3. And then we know that we can multiply those two. 3 times 1/3 will give me 5 to the power of 1. 64, 64 equals shift fact, that's going to give me 2 to the power of 6 to the power of 1/6. And then I can just multiply those two. That is going to give me 2 to the power of 6 times 1/6 is 2 to the power of 1. That's nice and easy. We can do that. That's not a big deal. All right, over here, I know I'm going to have to take the 16 part of it and put it as a product of its prime factors. So I'm going to get 2 to the power of 4a squared all to the power of 1/4 times a to the power of half. Now, I'm going to distribute these two in, and I'm going to get 2 to the power of 4 times 1/4 will give us 1. A to the power of 2 times 1/4 will give us a half. Multiplied by this half that's sitting on the outside, a to the power of a half on the outside. Right, and that will give me 2 to the power of, over here, I've got like bases being multiplied. So I'm going to keep the base, and I'm going to add my exponents. A half plus a half will give me 1. That's the answer I'm looking for there. All right. In this last one over there, I'm going to take 27 and write it as a product of its prime factors. So I will get 3 cubed y to the power of 6 all to the power of 1/3 multiplied by y to the power of -1. And that's going to give me, we need to distribute, that's going to give me 3 to the power of 3 times 1/3 is 1. Y to the power of 6 times 1/3, which is 2, multiplied by y to the power of -1. Okay, that's equal to 3. Over here, I've got like bases being multiplied. I'm going to keep my base of y and add my exponents. 2 plus -1 is just the same as 2 minus 1. So this is just y to the power of 1. How did we do? How much did we get out of 4? 1, 2, 3, 4. Well done, Kulani. Nice. Everyone else, how did we do? These are pretty easy, and these are the baseline ones. Oh, Theo, did we see where we got, those of you who got 3, are we seeing where we may have missed it a little bit? All right. Okay, excellent stuff. We just need to make sure that we're checking for those small things, because this is what is going to happen next. Let's step it up. Let's do questions 1 and 2. Remember, we're still working with rational exponents. Excuse me. Because there's a half on the outside. So make sure that we're doing our due diligence there. Okay, I'm just going to tell you guys now. No, actually, never mind. The answer is still going to come out okay. You can do what you need to do. I appreciate that emoji a lot more, Theo. Thank you. And as soon as I say that, I start coughing along. Oh my goodness. All right, guys, let's have a chat about these questions. Okay. Oh, we'll go see finish just in time. All right, let's talk about this one over here. Now, if I take 36 and I put it into my calculator, I'm going to get 2 squared times 3 squared times x squared all to the power of a half over 3x to the power of -1. All right, so we're then going to multiply each of those with that, and we're going to get 2 to the power of 1 times 3 to the power of 1 times x to the power of 1 over 3, which is just 3 to the power of 1. But this x to the power of -1 has a negative exponent. So I'm going to take it from the bottom. I'm going to bring it up so that it can have a positive exponent. So this thing then sits here, times x to the power of 1. Right? So 3 to the power of 1 and 3 to the power of 1 will cancel. And what I've got left on the top is 2x squared. That's my final answer at the top. All right, let's look at number 2 quickly. Number 2, we're going to do the exact same thing, guys. I'm going to take 64 and put that into my calculator. My calculator is going to tell me that that is 2 to the power of 6, x to the power of -6, all to the power of 1 over 3, over 2x to the power of 3. Right, and then we're going to distribute. On the top, I'm going to get 2 to the power of 2 times x to the power of -2 over x cubed, or 2x cubed. Over here, I'm going to notice like bases being divided. So I'm going to keep my base and subtract exponents. That's just going to give me 2 to the power of 1. This negative exponent over here must go to the bottom. So I'm going to end up with 2 at the top, and at the bottom, I'm going to have x to the power of 3 times x to the power of 2, which is then 2 over x to the power of 5. Okay, there's one mark. There's one mark. How did we do out of 2? I know the questions really aren't worth 2 marks. They're worth a little bit more. I just want to gauge how many of the questions we got correct. Well done, Theo. Lani got 1. Was it the first one or the second one? I'm going to guess it's the first one. The first one was quite easy. The second one was a little bit more challenging. I'll give you that. All right. But remember, guys, we're taking everything we've learned about maths and we're employing it all together in these kinds of questions. All right. One more question, and then we're going to call it, because it is actually quiz night and it is actually a holiday. So let's do this one. Theo, are you counting my coughs? Michael Jackson. There was a Michael Jackson last year, but I need to meet this famous person. All right, let's try this last question, guys. I'm only going to give you 2 minutes for this so that we can go through corrections. So try to employ everything we've learned so far. Oh my goodness. I need to meet them. I must go ask you guys. You had Teacher Cat, right? You guys had Teacher Cat. So I need to now ask Teacher Cat. Teacher Cat, explain. Explain yourself. What's happened here? I'm going to go ask her exactly what this is about, because now I have to know. Narisha goes, guys. I'm asking Teacher Cat exactly what you guys are talking about. Okay, don't forget, guys, we're still doing the question on the screen. Ah. Focus, guys. Let's focus. Let's focus. We've got less than 1 minute left. All right, guys, that's time. Okay, all right. So it's very important for us to remember, guys, that when we're doing these kinds of questions, we're still employing the same rules we know about exponents. We're not changing anything. The only difference is just that we have like base, or it's just that we have fractions in these. Okay, so if we go ahead and we do this question over here, at the top, I'm going to get 49 is 7 squared, x squared, all to the power of 1 over 4, over 7 cubed, all to the power of a half, times x to the power of negative 3 over 2. All right, so let us multiply everything in. Right, we're going to multiply in. So what I'm going to get over here at the top, I'm going to get 7 to the power of, I now have 2 times a quarter. That's going to give me 7 to the power of a half times x to the power of a half over 7 to the power of 3 times a half will give us 3 over 2 times x to the power of negative 3 over 2. Now, remember, guys, these are like bases being divided. So I'm going to keep my base. And what am I going to do with my exponents? What am I going to do with my exponents, guys, if I'm dividing my like bases? What must happen to my exponents? Anybody remember? It's not the hard part. Yes, Kulani, absolutely. We must subtract our exponents. So I'm going to get 7 to the power of a half minus 3 over 2 times x to the power of a half minus, now there's already a negative there. So this then becomes a half minus negative 3 over 2. And we know that these two minuses are going to give me a plus. So we're actually adding negative half plus 3 over 2. Okay, and then we just need to do the maths. Over here, I'm going to get 7 to the power of a half minus 3 over 2 is going to give me negative 2. Let me just make sure I'm not lying. Negative 1, sorry, negative 1. 1 minus 2, 1 minus 3 is 2 over 2, so that's negative 1 times x to the power of, now I'm adding over here 1 plus 3 over 2 will give us 2. Guys, if we're having a bit of trouble with the answers to these, we can easily just put these in our calculators and get an answer, especially with the fractions, because they do get kind of tricky. Pick up a calculator, pop it in and see what happens. All right, this is then going to give me, remember this is a negative exponent, so it can't sit there, it must sit in my denominator. So I'm going to take this and put it at the bottom. So my final answer should be x squared over 7. All right. How did we feel about that one? Are we all good? Everybody okay?